Hello, everyone. I just wanted to take some time to go through one of the more complicated calculations that we do in the Analytical 2 lab, and that's looking at calculating the concentrations of our analytes from GC data or from chromatography data using an internal standard. So when we're going to use this, it's going to be in both the percent recovery calculations and in the calculation of an unknown, where we have a concentration that we're trying to determine concentration of our analyte based on the results from our chromatography. Now, when we're looking at these calculations, it is usually fairly obvious what formula we're going to start with, and that is going to be the one where we have the C unknown is equal to C internal standard over F times the area of the unknown over the area of the internal standard. So that's fairly straightforward. We look at the formulas in the lab manual and we say, okay, yeah, that's the chromatography one, that's what we need. The areas are really easy. We're just going to look those up on our chromatography report. We need the area of the unknown, which is our analyte, and we need the area of the internal standard. In the GC experiment, we have two internal standards. We use progesterone, which is P, and we use estriol, which is E3. Our unknown is estrone, which is E1. F is the factor that accounts for difference in detector response to the internal standard versus the analyte, and that's calculated from running our standards. So we have a solution that we know all the concentrations in, and we run that and we can calculate F. So that's just calculated from our standard run. That's pretty straightforward. Where we're really going to focus in on this calculations is the two concentrations. So the concentration of the internal standard and then the concentration of the unknown. And the key thing with this calculation is that those two concentrations are in the same solution. So we need to look at our procedure and see where did we mix in the internal standard with our analyte, and what volume was that solution, because both of these concentrations, the C internal standard and the C unknown, are the concentrations after mixing. So they are diluted concentrations. We can't use the concentrations off the bottle that was given us for the internal standard. We need to account for that dilution. So this formula is always bracketed by dilution calculations. So you're always going to have a C1, sorry, C1V1 equals C2V2 on one side, and this is going to be for the internal standard. You're going to have to do that first. And then when you're done, you're going to need to do a C1V1 equals C2V2 again, but this is going to be on the analyte or the unknown. Okay. And when we look at C1V1 equals C2V2, what we're talking about here is the concentration of the stock times the volume of the aliquot is equal to the concentration in the dilution times the volume of the dilution. Sorry, dilution. So in the case of the internal standard, concentration of the stock will be given. Volume of the aliquot, that's pretty straightforward. That'll be in your procedure. The concentration of the dilute, that's what we're looking for, because that's what needs to go in for concentration of internal standard in this calculation. So it's the volume of the dilute that we really want to focus on, is what is this value right here, because that's what we need in order to be able to do our calculations. When we go to the other side, after we've done our chromatography calculations, now we're looking at, again, a C1V1 equals C2V2. Again, it's concentration of stock, volume of the aliquot, concentration of the dilute, and the volume of the dilute. But in this case, we have the concentration of the dilute. That's what C unknown will be. That will be the diluted concentration. We should know our aliquot volume from our procedure. We're trying to find C1. That's what we're looking for. But again, we need V2. If we don't know V2, we can't do the calculation. And the key thing here is that the two V2s are the same. So if we can figure out what V2 is, then we can figure out what we're using in our calculations, and everything from there should be straightforward. So in order to figure out what that dilute volume is, we need to look at the procedure, and we need to look at when did we add the internal standard in that procedure and what was the total volume of the solution. So let's go and look at the procedure for the GC experiment. So for the GC experiment, you started off with, you have a conical tube, and into there you put water. You put an aliquot of your analyte, okay, which is E1, that's estrone. And you have an aliquot of internal standard, which in this case is progesterone, which is P. So all of those are mixed together. And so let's fill up our conical tube with water. It's mostly water that's in here, and then you add small amounts of the two chemicals, the analyte and the internal standard. So we need to know the total volume there, and we get the total volume by adding the volumes of all three. So it's a little over 10 milliliters. It's mostly water, that's the 10 milliliters, and then the analyte aliquot and the internal standard aliquot add a little bit more to that volume. So that is our V2. Right, so our V2 that we have up here in our calculation, or V dilute, that is the volume, that little over 10 milliliters, and you're going to calculate an accurate volume that we're going to use in our calculations where progesterone is the internal standard. So we will calculate the dilute concentration of progesterone in that little over 10 milliliters. From our middle calculation here, we will get out the concentration of our unknown, our analyte, which is the estrone, from that in the dilute solution, and then we can work backwards to what the concentration was in our unknown solution, or in the case of the recovery, what you're going to actually do is figure out the milligrams of estrone that were in your unknown solution. But in this method, we actually use two internal standards, so we have to look at the other one as well. So for the other one, we have to look at, again, where was it added in the procedure? So this mixture that we have here was put into an SPE column. So an SPE column looks something like this, has a tap coming off the bottom, and drips. We get drips out the bottom, and it's filled with a resin. So I'm going to color the resin pink. It's not actually pink, it's white, but this is filled with a solid, and we take our mixture from here and we put it into here. So we put the mixture onto the resin, and then out of the bottom of the resin, we elute our analytes of interest into a small test tube. And that's done with methanol. So I'm going to change the color of the solvent. Let's just call it orange this time. So orange is methanol. So that's methanol. And we also at this point add in our internal standard, which is the E3, which is our estriol. So we add into this tube both, we have what eluted off of the column and our aliquot of the E3. The problem that we have here, we now have analyte and internal standard mixed together. That's great. We don't know the volume because we don't know the exact volume that comes off the bottom of the SPE column. We know how much we put in the top, but there's no guarantee that we got every drop of it out of the column. So we can't really calculate a concentration accurately at this point. And there's a standard method for getting around this problem, which is what we did in the lab, or you will do in the lab. And that is we evaporate this to dryness. So we have a heating mantle. It's just a block, looks sort of like this, and it has holes in it that hold your test tube. And then above it, we have another block. Looks like this. And it has, I haven't lined this up very well. It has tubes that come off of it that blow air into your test tube. So you put the test tube in the heating block, warm it up a little bit, you blow air through it, and all the methanol evaporates. And so you end up with a test tube that is essentially empty and just has a little bit of residue down at the bottom. So it's evaporated to dryness. And then we add to it 100 microliters of methanol. And so that 100 microliters, we know accurately. We have an accurate volume on there. So that's going to be our V2 when we're using the E3. So this will be our V2 when we're using E3 as the internal standard. So when we're using the estriol, our V2 is 100 microliters. When we're using progesterone, our V2 is a little over 10 milliliters. And we can then calculate our corresponding concentration of dilute unknown, and then work our way to a concentration that it was in the original sample, or the mass that was in the original sample. So hopefully that is helpful for everybody for doing this calculation. And if you have any further questions, you can talk to your TA or you can come and talk to me. Thank you.